wherever a magnet is moved towards or away from a conducting coil, magnet is moved towards or away from a conducting coil, an EMF is induced and the magnitude of which is independent of EMF induced in a coil. See, we are having a coil and magnet, either it may be moved towards the coil or it may be moved away from the coil. In both the cases, due to motion of magnet, flux associated with coil changes and EMF is induced in it, and that EMF induced is minus d phi by dt. It is equal to, but flux phi is equal to what? NAB. NAB. Flux phi is equal to NAB into cos of theta. NAB cos of theta. Or E is equal to minus of ddt of NAB cos of theta, means EMF induced, it depends on number of turns in a coil. EMF induced, it depends on the strength of magnetic field, and EMF induced, it depends on the speed with which magnet is moved. ddt means EMF induced is also depending upon what? The speed. Greater the speed with which magnet is moved towards the coil, greater is the EMF induced. Smaller the speed with which magnet is moved towards or away from the coil, then smaller is the EMF induced, means EMF induced in a coil will also depends on speed with which magnet is moved. But here EMF induced in a coil is independent of resistance of a coil. So the correct option to our question is that the EMF induced in a coil is independent of resistance of a coil. So option A is the correct option for this question.